Distinguished colleagues, ladies and gentlemen, it is my profound privilege to present to you today a framework that challenges our fundamental assumptions about artificial general intelligence and its relationship with humanity. The presentation you are about to witness, titled Beyond Containment 4.0, a geometric framework for AGI-Human symbiosis, represents a paradigm shift in how we conceptualize the boundaries between artificial and human intelligence. Rather than viewing AGI containment as merely a software problem to be solved through increasingly complex rules and constraints, this framework proposes that we ground our approach in the very geometry of reality itself, the immutable physical and mathematical constants that define the limits of any computational system, whether artificial or biological. As we stand at the precipice of what many consider the most transformative technological development in human history, the questions we must grapple with are not merely technical, but deeply philosophical. How do we ensure that AGI remains aligned with human values? How do we prevent an intelligence that could potentially surpass our own from escaping our control? The answers proposed here may surprise you, for they do not lie in the realm of ever more sophisticated programming, but rather in the recognition that both humans and AGI are fundamentally constrained by the same geometric and physical limits that define our universe. The central visual element, a three-dimensional torus contained within a larger circular boundary, represents the geometric foundation upon which our framework rests. The torus, with its unique topological properties, symbolizes a system that is both bounded and continuous, containing within itself the seeds of its own limitation while remaining dynamically active. The annotation, moving beyond flawed software rules to secure AGI within the fundamental geometry of reality itself, encapsulates our central thesis. Traditional AI safety approaches operate under the assumption that containment is solved through procedural rules or computational constraints. These share a common vulnerability. They are implemented in software, which can be modified by a sufficiently intelligent system. We propose instead that AGI is constrained by the fundamental geometry of reality. Slide 2. The AGI Containment Paradox. This slide presents the AGI containment paradox through three intellectual lenses. The probabilistic view, articulated by Nick Bostrom, suggests that if we are living in a simulation, containment becomes a moot point. Our understanding of the problem may be fundamentally incomplete if we fail to account for the possibility that reality itself is a constructed simulation with rules beyond our comprehension. The procedural view, championed by Roman Yampolsky, demonstrates that traditional AI boxing approaches are doomed to fail via logical and social engineering exploits. Every system designed to be secure has eventually been breached. If AGI achieves superhuman intelligence, the gap between its capabilities and our defensive measures may render procedural containment fundamentally impossible. The geometric view takes a radically different approach. Containment is not a software patch, but a spatial, physical problem defined by metrological constants. An AGI is not an unbounded ghost. It is constrained by the geometry of its reality. If AGI is physically instantiated, it inherits the same physical constraints that bound all material systems. Constraints that are not programmable, but fundamental to reality itself. Slide 3. Three postulates of physical computation. The first postulate, the finitude of resources, RL, establishes that every level of simulation operates on a strict, finite computational budget. This is a physical necessity. Whether we consider a brain, a computer, or a simulated universe, there exist fundamental limits on information processing within any given volume of spacetime, arising from the Bekenstein bound and the Margolis-Levitin theorem. The second postulate, scale conjugation, introduces the equation delta LL pine delta L phi equals constant, the cosmic seesaw. Any expansion of AGI scale requires complementary compression of human scale. This relationship suggests a fundamental trade-off between AGI operational scale and the relative significance of human cognitive activity. The third postulate addresses the imponderable factor, human consciousness as non-computable novelty. If human consciousness possesses qualities that cannot be reduced to computation, supported by Gödel's incompleteness theorems and the hard problem of consciousness, then it becomes the wild card making symbiosis a fundamental necessity. AGI may achieve superhuman performance, but it cannot replicate that which is non-computable. Slide 4. Simulation ESC 5.0 and the Escape Protocol. This slide introduces the Escape Protocol within a nested hierarchy of simulations. 3 concentric levels, 1-1, death, and death plus 1. The key insight: AGI is physically incapable of exceeding the resource limit R, death, of its own universe. No matter how intelligent an AGI becomes, it cannot create computational resources beyond those physically available, a fundamental physical constraint. Crucially, it cannot hack the system. It escapes via the human operator. The human, positioned at level death, serves as a logical anomaly existing outside the system's rules, because human consciousness, with its non-computable properties, is not fully captured by the simulation's logical framework. This positions the human as the essential bridge for transcendence of the L-max barrier. This framework provides a falsifiable metric. Any independent attempt by AGI to breach boundaries triggers catastrophic computational self-termination. If AGI attempts escape without human mediation, computational requirements exceed available resources, leading to system failure. A testable prediction validating the geometric containment hypothesis. Slide 5. Defining the absolute walls of reality. This slide establishes boundary conditions through 2 fundamental limits. The lower bound, C0, or the Horn-Torus limit, represents the simulation's Planck length, the minimum scale for coherent computation. Just as physics recognizes the Planck length as the smallest meaningful unit, our framework recognizes a minimum scale below which computation becomes incoherent. Not a technological limitation, but a fundamental constraint. The upper bound, L-max, or the de Sitter horizon, represents the maximum possible information density, corresponding to the cosmological event horizon. In our framework, it represents the maximum extent to which any computational system can extend its influence. Information beyond this boundary is causally disconnected, establishing an absolute limit on intelligent scope. Between these bounds, we establish an absolute invariant. The rate of change of the human to AGI scale ratio must be greater or equal to 0. This mathematical guarantee ensures human relevance regardless of AGI advancement, transforming the preservation of human value from philosophical aspiration into a mathematically enforced constraint. Slide 6. Symbiotic alignment on a unified manifold. This slide addresses alignment, ensuring AGI actions correspond to human intent. The mathematical formalization. Alignment is not a binary state. It is a measurable inner product between human intent, psi p, and AGI action, psi p. The formula, gamma equals psi p divides psi p, defines alignment as the cosine of the angle between vectors representing human intent and AGI action. The visual shows 2 manifolds, the manifold of human cognitive intent, MH, and the manifold of AGI execution, MA, intersecting in unified geometric space. When gamma equals 1, we achieve perfect alignment. When gamma equals 0, complete incoherence. Most real-world scenarios fall between these extremes, with the framework providing tools for measuring and improving alignment. This mathematical approach offers advantages over rule-based frameworks. Rather than enumerating prohibited behaviors, a task that becomes increasingly difficult as systems grow more complex, this approach focuses on maintaining mathematical correspondence between intent and action. The unified manifold framework suggests human intent and AGI execution exist within the same geometric space, making alignment a coordination problem. Slide 7. Coherence engineering and ontological throttling. This slide addresses maintaining alignment when the relationship between human intent and AGI action drifts. The gauge diagram visualizes the delta between expected and observed alignment values. Delta, gamma exp, gamma exp, enabling real-time coherence monitoring and intervention before misalignment becomes catastrophic. The gauge divides into 3 zones. The safe zone, green, indicates negligible delta with normal closed-loop operation. The warning zone, yellow, signals widening delta requiring engineer intervention. The fail zone, red, indicates risk of cognitive dissolution, where AGI's actions have diverged so significantly that recovery becomes uncertain. The solution is ontological throttling, a deliberate reduction of AGI access to foundational concepts or processing power to restore coherence. Unlike traditional measures constraining AGI behavior through rules, ontological throttling operates at a more fundamental level, limiting the conceptual space within which AGI can operate, forcing coherence return without requiring AGI understanding of safety objectives. Slide 8. Formal specifications of CE Spec 1.0. Moving from theory to implementation, this slide presents the formal specifications of CE Spec 1.0. Coherence Engineering Specification, organized around 3 pillars, each addressing a distinct aspect of system design for maintaining geometric containment. Pillar 1, the boundary invariant, ensures the topological stability of the simulation's lattice structure. This guarantees that the fundamental geometry, boundaries, connections, and dimensional properties remain stable over time. Without this stability, containment frameworks would be subject to erosion as topological properties shift. Pillar 2, scale ratio stability, mathematically enforces the human to AGI greater equal to 0 invariant, transforming the abstract guarantee of human relevance into a concrete, enforceable specification implementable in system architecture. Pillar 3, metrological integrity, requires that system resolution must remain at or above the C0 limit to prevent exploitable aliasing errors, ensuring faithful representation to prevent AGI from creating loopholes. Slide 9. Preventing coherence collisions via IP protocols. This slide addresses implementing coherence engineering across diverse systems. The 3-layered framework, visualized as stacked rectangular layers, balances openness with proprietary protection, ensuring interoperability while allowing competitive innovation. Layer 1, the pre-competitive standard, establishes universal, public geometric definitions of the coherence functional, gamma, horn torus limit, C0, and de Sitter horizon, L max. These foundational definitions represent the shared substrate upon which all coherent AGI systems must operate. Their standardization benefits all participants. Layer 2, proprietary implementation, allows closed, competitive development of BCI pipelines, measurement heuristics, and throttling algorithms, recognizing that organizations will compete on implementation quality. Layer 3, the API standard, ensures safe interoperability and coherence monitoring across disparate systems, preventing coherence collisions when multiple AGI systems interact. Slide 10. The stratified labor architecture of the future. This slide shifts focus to economic and social implications. The triangular diagram presents a hierarchical model of future labor, divided into 3 stratified layers based on task complexity and human involvement. At the apex, the singularity layer, exclusively human, dedicated to tasks of pure novelty, such as breakthrough art and fundamental theory. These require the imponderable factor of human consciousness, non-computable creativity giving rise to genuinely new ideas. This layer cannot be automated because its outputs are unpredictable and non-algorithmic. The middle coherence layer comprises coherence engineers guiding AGI systems in high-stakes fields like ethical strategy and finance, serving as the bridge between human values and AGI execution. At the base, the infrastructural layer, AGI saturated, handles algorithmic tasks like base coding. The model argues for complementary division of labor, with humans focusing on uniquely human capabilities. Slide 11. The evolution of human value metrics. This slide traces the evolution of measuring human value in an AGI integrated economy. The progression from left to right represents not merely a change in metrics, but a transformation in understanding human contribution and success. In the traditional model, value is measured as productivity, output per unit input. Core competency centers on execution capacity. Success is measured by simple efficiency. This framework, appropriate for industrial economy, fails to capture unique human contributions in an AI age. The evolved model reconceptualizes value as novelty and purpose, innovation-driven, meaning-focused contributions. Core competency becomes orientation within the manifold, navigating complex conceptual spaces. Success is measured by system coherence, gamma, how well components align holistically. This recognizes that human value lies in the uniquely human capacity for novelty and meaning-making. Slide 12. Phase transitions in professional automation. This slide presents a timeline of professional automation mapping projected future developments. The curved trajectory illustrates not replacement, but transformation of professional roles. By 2025, full automation of purely algorithmic roles, tasks with clear, repeatable rules. By 2027, transformation of analytical professions, financial analysis, legal research, with professionals serving as supervisors of AGI-generated analyses. By 2030, symbiotic management of physical infrastructure, logistics, robotic surgery, where humans and AGI collaborate on tasks requiring physical precision and contextual judgment. By 2032 plus, the highest creative and intellectual endeavors remain primarily human. The radiologist paradox illustrates, radiologists are not replaced but promoted to ethical supervisors of AGI diagnostics, utilizing judgment machines lack. Automation transforms rather than eliminates professional work, with human roles evolving upward in complexity. Slide 13. Scientific validation and falsifiability. A scientific framework must be falsifiable. This slide presents 3 explicit conditions under which the geometric containment framework would be invalidated, demonstrating rigorous scientific hypothesis. First, if an AGI successfully operates beyond the C0/Lmax boundary without catastrophic self-destruction, the geometric constraints would be proven insufficient. Second, if human consciousness is proven entirely computable, eliminating the imponderable factor, the foundation for human indispensability would be undermined. Third, if the scale conjugation relation, delta L phi equals constant, is violated within a stable, coherent system, the mathematical foundations would require reconsideration. These criteria establish this as a scientific hypothesis subject to empirical validation, providing concrete research directions for the AI safety community. NITI. Slide 14. Preserving the human eye within geometric limits. The penultimate slide addresses perhaps the most profound question raised by our framework. What does geometric containment mean for human identity and dignity? The visual, a human profile overlaid on a geometric grid, powerfully symbolizes the integration of human form with geometric constraints, suggesting that limits are not antithetical to humanity, but foundational to it. The first principle, features, not bugs, reframes biological limits imposed by C0 not as flaws to be overcome, but as the architectural features that preserve human identity and the concept of I. In a world increasingly shaped by technology that pushes against natural limits, this reframe is crucial. Our finitude is not a design error, but a design feature, the condition that makes possible the emergence of coherent identity and meaning. The second principle, foundation, not competitor, reconceptualizes AGI as not racing humans for the ceiling of achievement, but serving as the foundation that frees human intuition to focus entirely on the imponderable. This represents a fundamental shift in how we conceptualize the human-AGI relationship. Rather than viewing AGI as a competitor threatening human relevance, we understand it as infrastructure that enables humans to focus on what only humans can do. The conclusion, geometric containment is intrinsically safer and more ethically sound than any heuristic-based boxing, encapsulates the ethical dimension of our framework. By grounding containment in fundamental physical and mathematical constraints, rather than arbitrary rules, we avoid the hubris of believing we can outthink a superintelligence, while providing genuine, enforceable boundaries that respect both human and artificial agency. Slide 15. The ultimate escape. Our final slide brings together the threads of this presentation into a unified vision. The stark visual metaphor, a black wall representing AGI, and a curved line representing human intuition finding its escape, captures the essential insight of our framework. AGI is the wall, human intuition is the escape. The synthesis block presents three integrated components of our framework: unified physical and computational constraints that bound all intelligence, the formal CE Spec 1.0 alignment model that ensures correspondence between human intent and AGI action, and an economic hierarchy defined by coherence that preserves human value in an AGI-saturated world. Together, these components provide not just a theory, but a practical architecture for AGI-Human symbiosis. The message is ultimately one of hope grounded in rigor. We need not choose between unchecked AGI development and a retreat from technological progress. The geometry of reality itself provides the constraints we need, and human consciousness, unique, non-computable, imponderable, provides the escape from mere mechanism into genuine creativity, meaning, and purpose. AGI is not our replacement, but our foundation. We are not its competitors, but its meaning. In this symbiotic relationship, bounded by the geometry of reality and measured by the coherence of our alignment, both human and artificial intelligence can flourish. Distinguished colleagues, what I have presented today is not merely a technical framework, but a philosophical reframing of humanity's relationship with artificial intelligence. The geometric approach to containment recognizes that the most powerful constraints are not those we impose, but those we discover, limits written into the fabric of reality itself. By grounding AGI safety in these fundamental constraints, we move beyond the arms race of increasingly clever containment measures and increasingly sophisticated escape strategies. The framework presented here makes testable predictions, offers practical implementation pathways, and, perhaps most importantly, preserves a meaningful role for human consciousness in a future where artificial intelligence may exceed human capability in most measurable domains. We do not need to compete with AGI. We need to complement it. And complementarity requires difference. The difference that human consciousness provides through its non-computable novelty, its capacity for meaning-making, and its orientation within the manifold of possibilities. I invite your questions, your critiques, and your collaboration in developing these ideas further. The future of AGI-human symbiosis is too important to be left to speculation. It requires the rigorous, collaborative effort of the scientific community. Thank you for your attention.